Welcome to the School of Life. Life is hard, but you have got to be harder. I am Mrs. Collins, your life coach. Let's get started with Unit 3, Lessons 5 and 6. In Lesson 5, we are going to learn how to analyze and graph absolute value functions. We begin with the parent function, y equals the absolute value of x. Very similar to other functions that we've learned how to graph, the absolute value function has a bonus feature, and that bonus feature is that it includes a vertex. The vertex in this case is 0, 0. Remember that we can pick out this vertex by looking at your h and your k from our equation. And if we're looking at our equation, inside of our absolute value brackets with x would have been our h. Since it's missing, it's automatically a 0. And then outside of our bracket at the end, we'd have our k, which is our constant. Also, it is missing, so therefore our k is also 0 by default. So our vertex is 0, 0. When graphing, we usually write that the vertex in the middle, so 0, 0, if it includes a vertex. So here we have our vertex, V-E-R-T-E-X. And then, just like before, we'll choose numbers for our x coordinate that are around our 0. So the number before 0 would be our -1, and then going backwards, -2. Going forward from 0, we have 1 and 2. When we're looking to figure out our f of x values, what we're going to do is take our equation, y equals the absolute value of x, and plug in our x. So y equals the absolute value. Our first one is a -2. And so the absolute value of a -2 gives us 2. So this one is 2. And if you're thinking about, well, what is absolute value? Absolute value is how far is -2 away from 0. -2 is 2 away from 0. And so therefore that's how we got this 2 here as our answer. Going to the next one, we have y equals plugging in our -1. So the absolute value of -1. -1 is 1 away from 0. So our answer is 1. Okay. For the next one, y equals the absolute value of our 1. And so if you're thinking about, well, how far is 1 away from 0? It's 1 away from 0. So 1. And then the last one, y equals the absolute value of 2. And when you're thinking, well, how far is 2 away from 0? It is 2 away from 0. So it's 2. Next thing, we'll graph it. All right, so here we have our graph. So our graph of the absolute value function looks like a V. Whenever we graph it, it looks like a V. Our domain for our absolute value function is all real numbers. Remember, that's all of the possible x values. And our range is very similar to how we figure out our range for quadratic functions. We're looking at all possible y values. So for this V shape, we have either a minimum spot or a maximum spot, and that's where our vertex is. In this case, this is a minimum. So our y's don't go anywhere below the y value of a 0 here. And then we cover all the y's above it. So then our range here would be y is greater than or equal to 0. As for our end behavior, as x approaches -infinity, so that's on the left. So as we're going left, our graph is going up. So y is going towards +infinity. For the second one, as x goes to +infinity, so that's as our graph goes towards the right, our graph is going up, or will end up, up. So therefore, we're going towards +infinity as well. All right, so here we're going to find the indicated information for each graph. I have already drawn in our parent function. So this is what the parent looks like, the blue one. And then our red one is our newest function. So we want to think about the transformations that occurred from the parent to, you can think of it as an offspring. So the parent to its offspring, the parent to the newest function. I like to always look at the vertex of the original and compare it to the new vertex of the vertex of the new graph. So in this case, you will notice that the original vertex here was at 0, 0 for the parent. We'll notice that for the new function, it has been moved up 1. So one of our transformations is up 1. It hasn't shifted to the left or to the right, so there's no left or right shifts. Okay. The next thing that you should notice is that this one is narrower than the other. So it's skinnier. Notice that the parent function is wide. This one is skinnier. So you can say that it is narrow. Okay. And those are our two transformations for this one. The vertex for our new function is at the point 0, 1. So this is the point 0, 1. So our vertex is at 0, 1. The domain is all real numbers. And our range, our red function does not go below the y value of 1. So therefore our range is y is greater than or equal to 1. As for end behavior, as x is going towards the left, so towards negative infinity, our graph is going, so as we're going left, traveling left, our graph is going up, 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 so to positive infinity. As x is going towards positive infinity, which means as we're going towards the right, our graph is traveling up, so y is going towards positive infinity. All right, so try number 2. We have our parent function in blue, and then we have our new one in red. So as we're thinking about the transformations, one, note that your vertex for the parent function is at 0, 0. Our newest vertex is here at -2, -1. So that's where our new vertex is, -2, -1. Notice that it has been shifted to the left by 2 and down by 1. So those are two transformations, left 2 and down 1. The next thing you should notice is that your parent function is sitting upwards, but the new function is flipped upside down. That's a reflection. So that's another transformation of ours, reflection. Right, the domain is all real numbers for our absolute value functions. And our range, well, let's look at the highest y value that we can have for our graph. The highest y value that we can have is a -1, and then everything below it. So then this would be y is less than or equal to -1. As for our end behavior, we have as x approaches the left, so as it's going towards the left, negative infinity. So going towards the left, we are traveling downwards. So y is going to negative infinity. As we go towards the right, so as x goes towards positive infinity, we are traveling once again downwards. So y is going to negative infinity. All right, so number 3 is a you try problem. Please pause the video and try the problem. All right, and we have our answers. For this one, our blue is our parent function. We're comparing it to its changes that have been made with the red one. We have a reflection. It's upside down. It is narrow, so it's not as wide as the blue one. We shifted right by 1 as far as our vertex, and up by 4 is where our new vertex is. So the vertex is at 1, 4. We have our domain of all real numbers. Our y is less than or equal to 4 is our range. And then we have our end behavior. All right, so let's graph some absolute value equations. Now, the very first thing that we want to do is something we've done before. We're going to point out the transformations based on the equation that we're given. So let's first identify our A. Our A, we have a -1. So that means that we're going to have a reflection because our A value is negative. Next, we have our H. In this particular case, our H is not a negative 1, but our h is actually 1. We always go with the opposite for our h. So this means that we have a shift right 1. And then we have our k value here. Our k is equal to negative 3. So therefore, we are going to go down by 3. All right, so in the middle of our table, we're going to place our h and our k. So in the middle, we have our h and our k. Our h is 1 and our k is a negative 3. So that's in the middle of our table. From there, we're going to come up with our x's around 1. So going backwards from 1, we're at 0 and then negative 1. Going forwards from 1, we're at 2 and 3. We are now going to use Desmos.com in order to come up with the rest of our values for our function, simply so that we are limiting the amount of work that we're doing by hand. To continue with our graphing of our absolute value function, we're going to use Desmos.com so that we can come up with a table of values. So in Desmos.com, I've typed in our first equation, y equals negative the absolute value of x minus 1 minus 3. If you're looking to figure out where these absolute value brackets are, you can go onto your keypad and you're looking for the straight line. So just make sure that you look for it on your keypad. Okay, in order to access the table, we're going to go to our edit list here, and then we're pressing the icon for convert to table. And here is our table. Notice that in our notes, we have our vertex in the middle, and our vertex was 1, negative 3. So I'm going to change the middle to 1, and then automatically the y's update to that negative 3. Above it, we had our 0, so let's change it out to 0, and we have negative 1. And then below our vertex, we have the number 2, and we have the number 3. So these are our outputs, negative 5, negative 4, negative 3, negative 4, and negative. And that's all. You should notice how your graph has changed, and we have all 5 of those points plotted here. So these are the points that you'll need to plot on your coordinate plane. Here are your values. Okay, so we have negative 5, negative 4, negative 3, negative 4, and negative 5. If we go ahead and plot these order pairs, then we have the following graph. And here's our graph. You notice that the vertex here is at 1, negative 3, just as described here, as well as what we pointed out from the equation. We have a right shift. So here was the original. We shifted once to the right and then down 3. And that was where our new vertex is. Okay, when we're thinking about the domain, the range, the vertex, the end behavior, well, we just identified the vertex. The vertex is with 1, negative 3. The domain, all real numbers. Your range. Range, well, we're going to have a highest y value here. This is the highest point of our graph. And all of the y values are either negative 3 or below. So this will be y is less than or equal to negative 3. Our end behaviors, as x goes towards the left, our y's are going down, so towards negative infinity. And as x goes towards the right, our y's are going down towards negative infinity. All right, so we have number 2. Number 2, first off, looking at our equation and identifying the transformations. We have a 2 out in front. That's an a value of a 2. That means that we have a stretch of 2. And we have an h value. H, remember it's the opposite number, so a negative 1. And our k is missing, so we have a k value of a default of 0. So our h and k goes in the middle, so we have a negative 1 and a 0. Coming up with the values for our x, let's go backwards from negative 1. You have negative 2 and negative 3. And going forwards, you have 0 and then 1. Let's use Desmos.com to come up with our other values. So after plugging in -3 here, -2, and so on and so forth. All right, so we have our values. And then let's go ahead and plot our ordered pairs. All right, so we have our parent function, which was the blue one. And then our newest one is the black one. Notice that, we forgot to write our other transformation. Because we had a transformation, our h value was a -1. That meant that we were going to go towards the left 1. Okay, and that k of 0 meant that we moved up or down. We didn't have to move up or down. So notice that our new vertex is simply shifted left 1. And then we have a stretch of 2. It is nearer by 2. Our domain is all real numbers. Our range, well, our y values don't go below our 0 for y. So then our range is y is greater than or equal to 0. Our vertex is at the point -1, 0. Our x-intercept, so that's where on the x-axis is our graph touching or crossing, and here it's at -1. So this is the point -1, 0. Our y-intercept, where on the y-axis is our graph crossing, and it crosses here at the point 0, 2. So 0, 2 is the y-intercept. In behavior, as x goes towards the left, our y's, our graph, as we're going left, is going up. So it's a positive infinity. And as x goes towards the right, our graph is also going up towards positive infinity. All right, the last one for lesson number 5 is a U-try problem. So let's go ahead and identify our transformations together, and then you'll go ahead and graph it and fill in the other information. So we have an a value of -3. That means that we have a reflection because it's negative. And we also have a stretch of 3. TCH of 3. We have an h value, remember the opposite, so -1, it just becomes a +1. So that means that we are going towards the right by 1. And then we have a k value of 4, so that means that we're going up 4. Okay, vertex for the middle of our chart will be a 1, 4. Please pause your video and fill out the rest. All right, and here we have our answers. Please check your work. All right, so we're also going to talk about lesson 6 in this video, analyzing square root functions. We're going to learn how to analyze them as well as graph square root functions. Now, these are a little bit different from the functions that we've gone over in the past, so like our cubics, our quadratics, as well as lesson 5, which was our absolute value functions. So please pay close attention to the little differences here. So starting off, our parent function is y equals the square root of x. It's the most basic of our square root functions. Y equals the square root of x. Okay. With this, there's several new things to note. One, there's a special note. For square roots, there's only one arrow, so it only goes in one direction here. Okay. Second thing to note is that we've been talking about like the h and k value being a vertex. In this case, our h and k value is like our tip or our head of our arrow, or the roots base of our arrow, and then we continue going in one particular direction. So instead of putting 0, 0 in the middle of our table, we place it at the top, and then we fill in the rest of our x values and then do our calculations for our outputs. The domain for this particular parent function is x is greater than or equal to 0. So that's all of our possible x values. All of our possible x values for this one starts here at 0, 0 and continues to go. So we have x is greater than or equal to 0. And our range for this one, all of the possible y values, is y is greater than or equal to 0. As far as the end behavior, since it only has one end, We are only looking at as x is going towards the positives, or as x is going towards the right. So as x is going towards positive infinity, so that's towards the right, our graph is constantly growing and going up and up and up. So our y's are going off towards positive infinity. So that means that we are going to be wider. We have an h value of, remember the opposite of -5. But inside we see that +5. So that means that we have moved to the left by 5. And then notice that we don't have a k there. So k by default is 0. So that means that we shifted none up and none down. So no up-down shifts. All right, number 3. Number 3 is a U-try problem. Please pause the video and try it out. All right, so we have an a value of -1. So therefore we have a reflection. Our h, go with the opposite that you see, is a 1. So that means we're going to the right by 1. And then our k value is a -3. So that means that we're moving down by 3. All right, so once it comes down to graphing our square root equations, very similar to the others that we've talked about in previous lessons, we're first going to identify those transformations. So out in front, our a is simply a 1. That means that there has been no shifts. Our h would be inside of our absolute value symbol with our x. However, there's nothing there. So h by default is a 0. And then we also have our k value at the end. So k value is a 4. So this one does give us a transformation. We're going to move up 4. All right, so in this case, we place our h and our k at the top of our equation of our chart this time. So this time we'll have our 0, 4 at the top. And then we come up with the x values that are greater than our 0 in this case. So next we have 1, then 2, 3, and then 4. All right, so this one we're going to calculate by hand to figure out each of the outputs. So if I have f of x equals the square root of x plus 4, and I want to plug in our first number, which is 1 plus 4, so the square root of 1. The square root of 1 is 1. And then we have our plus 4. 1 plus 4 gives us 5. So this output is a 5. Okay, when we do our next one, we have f of x equals the square root of, the square root of x plus 4. This time we're going to plug in our 2 for our x and then plus 4. The square root of 2 is an irrational number, and that irrational number is about 1.414. And then we're still adding on that 4 at the end. So this gives us about 5.414. So this is about 5.414 with a bunch of digits at the end. This is an irrational answer. All right, once we go to the next one, we have f of x equals the square root of x plus 4. We are going to plug in this time our 3 and then plus 4. So the square root of 3 is another irrational number, which is about 1.732. And then we're adding on this plus the 4. So that gives us about 5.732. So this is about 5.732. And those digits go on as well. The last one we have is f of x equals the square root of x plus 4. So it's the square root. This time we're plugging in our 4 and then plus 4. The square root of 4 is 2 and then plus 4. 2 plus 4 gives us 6. So this one comes out to be about 6. Okay, let's plot these points. Of course, with these decimal answers for our outputs, it'll be a little bit difficult for us to figure out those. So we're going to plot these three order pairs. So the ones that we definitely know we can plot. So let's plot them. All right, and we have our newest function. Notice that our only shift was that it would move up by 4. Looking at where the head of this is, it has moved up by 4. Okay, from there, we'll go ahead and identify the domain. The domain is all of our possible x values. Well, as far as x values, the x values don't go beyond our 0 or below 0. So here our x values are x is greater than or equal to 0. As far as our possible y values for our range, well, this particular graph does not go below the y value of a 4. So therefore the range is y is greater than or equal to 4. In behavior, we only have 1 this time. And so as x is going towards the right, so towards positive infinity, our graph is growing upwards or going upwards. So then y is going towards positive infinity as well. All right, let's try a second one in graphing it. So again, identifying those key points transformation from our equation. So in this case, we have an a value of 2. So that means that we'll have a stretch of 2. Inside, we have our h. Remember, it's the opposite number, so a 3. And so in this case, we are going to go towards the right by 3. Shift right 3. And then lastly, our k value is missing. So the default is a 0. So it doesn't shift up or down. Okay, inside of our table, we're going to place our h and our k at the top this time. So h is 3 and our k value is 0. And then let's get x values that are greater than our 3. So next we have 4, 5, 6, and 7. Okay, at this point we're going to go ahead and use Desmos. We're going to make our table look or reflect 3, 4, 5, 6, and 7 in our x column, and then let's see what our outputs are. All right, so we have our values. The 3 coordinates that we're going to end up plotting will be 3, 0, 4, 2, and 7, 4. The others, with those outputs of decimals, they're just going to automatically fall apart our curve that we draw. So let's go ahead with plotting those points. All right, and here we go. So notice that we had a stretch of 2. So this is 2 times stretched. Also note that our head has moved right to the third. I'm sorry, right 3. So right 3 to the right. So from 0, 0, it's now at 3, 0. Okay, if we think about our domain is all of our possible x values. So in this case, the smallest x value that we have is a -3. And so we have x is greater than or equal to 3. I think I said -3, but I'm in a positive 3. So all of our possible x values are greater than a positive 3. So x is greater than or equal to 3. Our range, our smallest y value is a 0 here. So y is greater than or equal to 0. In behavior, there's only one statement. So as x is going towards the right, in this case, positive infinity, our y is, our arrow is going upwards. So therefore, we're going up towards positive infinity. All right, and we'll try one more together. So for number 3, we have an a value here of a -1. So a equals -1. -1. So that means that we have a reflection. Inside of our absolute value symbol, we have an h of, go with the opposite number, a -1. So this means that we are going to shift to the left by 1. And then lastly, we have a k value of -2. So that means we're going down 2. So our h and k goes at the top of our table. So h was a 1, and our k is a -2, so 1, -2. I'm sorry, there should be a negative 1. H was a negative 1. So negative 1 and negative 2. And then we are going to go up with our numbers. So next 0, 1, 2, and 3. And then we're going to go ahead and use decimals to fill in the rest of our table. All right, and so here we have our table of values. The 3 that we're going to plot are negative 1, negative 2, 0, negative 3, and 3, negative 4. All right, and here's our graph. As far as the domain, that's all of the possible x values. Well, our x values, we don't go any lower than our negative 1. So therefore, x is greater than or equal to negative 1. As for our range, that's our possible y values. Our highest y value is a negative 2 and everything below it. So then our range is y is less than or equal to negative 2. As for our end behavior, we only have one statement. So as x is going towards the right, so towards positive infinity, as we're going right, we are going down. So therefore, y is going towards negative infinity. Okay. For number 4, it's a U-try problem. Go ahead and try the problem. Let's first identify our transformations. A is a 1 as a default. Nothing was in front. Our H is the opposite of the number you see, so it's a 2. And so therefore, we have a right shift of 2. And then our K here is 4. So that means that we're going up by 4. Those two go at the top, 2, 4. Your other values for X, go up with your numbers, 3, 4, 5, and 6. And then go ahead and use your calculators to figure out the outputs, graph, and then find your domain, range, and end behavior. All right, and you have your answers. Please check your work.